Oceans cover more than 70% of our planet, and they're the life support system of Earth. They regulate our climate, absorb the carbon dioxide we pump into the sky, stabilize weather patterns, and serve as home to an extraordinary range of life that has thrived for millions of years. But beneath the surface of this vast blue frontier lies a crisis that is spreading silently, faster than most realize. It's not an oil spill, it's not plastic pollution. It's something even more insidious, something known as dead zones. These are not science fiction wastelands or Hollywood disaster scenes. They are very real, oxygen-depleted areas of our oceans where life itself is suffocated, where fish flee and ecosystems collapse. And here's the chilling part. They're growing bigger, deadlier, and more frequent every single year. Today, scientists have identified more than 600 dead zones across the globe, ranging from small patches of ocean to areas tens of thousands of square kilometers wide. To put it in perspective, some dead zones are bigger than entire countries. Once they were rare. Now they are spreading like a cancer across our seas, triggered not by natural cycles, but by the choices humanity makes. Every day, agriculture, industrial waste, sewage, our entire way of life is feeding this silent killer. And the oceans, once seen as too vast to ever be damaged, are showing us just how fragile they really are. So how exactly does a thriving ocean turn into a watery graveyard? The answer is deceptively simple. Too many nutrients. Every time fertilizers, rich in nitrogen and phosphorus, wash off farmland and into rivers, every time untreated sewage or industrial waste makes its way into the sea, the water becomes overloaded. At first, it doesn't look like a problem. In fact, all those nutrients fuel massive algal blooms, giant green clouds of microscopic plants that spread across the surface. But the beauty is an illusion. When the algae die, bacteria break them down, and in the process they suck the oxygen out of the water. What's left is a suffocating soup where fish, crabs, and even shrimp cannot survive. The water might look calm, but beneath the surface, it is a biological desert. Take the Gulf of Mexico. Fed by the mighty Mississippi River, which drains vast stretches of farmland across the central United States, the Gulf experiences one of the world's largest recurring dead zones. In some years, it has stretched over 20,000 square kilometers. That's about the size of New Jersey, completely barren of marine life. Fishermen here see firsthand the devastating impact. Shrimp and fish are forced to flee or die, leaving nets empty and livelihoods at risk. Imagine depending on the ocean for food and income, only to find that your waters are slowly turning into lifeless wastelands. That's not a distant scenario. It's happening right now, and it's not just the Gulf. The Baltic Sea, the Black Sea, Chesapeake Bay, and even parts of the East China Sea all suffer from massive hypoxic zones. Some last only through the summer, when warm weather and stratified waters lock oxygen out. Others are permanent. Entire stretches of coastline turned into ecological black holes. Even regions once considered untouched are no longer safe. Scientists have recorded hypoxia in remote areas, showing us that no ocean ecosystem is truly immune from this global crisis. But here's where things get even scarier. Climate change is making everything worse. Warmer water holds less oxygen, which means marine life is literally gasping for air. Rising sea levels alter coastal currents, trapping polluted water close to shore. Stronger storms and heavier floods wash even more nutrients into the sea, fueling larger algal blooms. And shifts in ocean circulation limit the natural mixing of waters that once replenished oxygen levels. Put simply, climate change and nutrient pollution are working together like partners in crime, supercharging the spread of dead zones across the planet. The ecological fallout is staggering. Dead zones collapse entire food webs from the bottom. Small species like plankton, shrimp, and juvenile fish die off first, and when they disappear, the larger predators that depend on them either starve or flee. The balance of life tips in favor of the few species that can tolerate low oxygen. Things like jellyfish, some bacteria, and invasive organisms. Picture oceans once teeming with diverse fish, now replaced by swarms of jellyfish pulsing through empty waters. Coral reefs, seagrass beds, and mangroves on the edges of these zones also begin to die back, leaving coastlines vulnerable to erosion and storms. Biodiversity plummets, ecosystems weaken, and the ocean's ability to provide critical services from carbon storage to natural water filtration is crippled. The economic impact is equally severe. Fisheries lose billions as stocks decline, forcing fishermen to travel further, spend more, and catch less. Coastal communities that rely on seafood for jobs and sustenance are left scrambling. Tourism suffers as once vibrant beaches and coral reefs turn barren or foul-smelling with algal decay. And when industries and families lose income, the ripple effects spread across entire economies. This isn't just an environmental issue, it's a human crisis, one that reaches from the ocean floor to our dinner plates. So is there hope? The answer is yes, but it requires action, and fast. Reducing nutrient runoff is the first line of defense. Farmers can adopt precision fertilization, planting buffer strips along waterways, or using cover crops to absorb excess nutrients. Wetlands, nature's own filters, can be restored to trap pollution before it reaches the ocean. Cities can upgrade wastewater treatment plants to remove more nitrogen and phosphorus before discharging effluent. These aren't hypothetical solutions. They've already shown success in places like the Chesapeake Bay, where targeted efforts have helped shrink the size of dead zones. Technology is also giving us new weapons. Satellites can detect algal blooms from space. Autonomous underwater drones now roam the seas, measuring oxygen levels in real time. Machine learning models predict where hypoxia will strike next, giving authorities time to act. Some researchers are even experimenting with artificial oxygenation, literally pumping air back into suffocating waters. While costly, these methods show that innovation can play a role alongside policy and sustainable practices. Global cooperation is another key. Many seas, like the Baltic and the East China Sea, are shared by multiple nations, meaning that no single country can solve the problem alone. International agreements, data sharing, and coordinated action plans are essential. After all, the ocean knows no borders. Pollution released in one nation can easily poison waters halfway across the world. Perhaps the most powerful tool, though, is awareness. When people understand that dead zones aren't abstract scientific terms but very real threats to food, jobs, and the health of the planet, they care. And when they care, governments and industries are pushed to act. Citizen science programs, educational campaigns, and media coverage are already helping turn the tide. But the fight is far from over. The story of dead zones is both a warning and a test. It shows us what happens when we push ecosystems past their breaking point. But it also offers us a chance to prove that with knowledge, innovation, and cooperation, we can repair the damage. The oceans are resilient, but only if we stop suffocating them. If we don't, the dead zones of today could become the new normal tomorrow, reshaping marine life, coastal economies, and even global climate in ways we may not be able to reverse. The question is simple. Will we act while there's still time, or will we watch as our oceans slowly suffocate? For more hard-hitting breakdowns on the planet's hidden crises, don't forget to subscribe, because the next big story might be even closer to home than you think.